Okay, in today's video, we're going to look at rearranging inequalities. Now, it's very, very similar to a rearranging formula when we have normal equations, but there's one little twist. So we'll get to the twist later. These ones are still pretty normal. So let's just take a look. Let's just write it as an equation. So I'm going to do this same thing. So this would look very familiar to you. And all we're going to do here is we're going to add 4 on both sides, or move the 4 over as we say it. And then it's a minus 4, it's going to be a plus 4 there. And then x would, dividing by 3 on both sides, would be 6. Okay, so very straightforward. With an inequality, it's exactly the same thing. We basically moving the 4 over, so I have a less than sign, and this becomes 14 plus 4. And then the 3x becomes smaller than 18, and divide by 3 on both sides, so x is smaller than 6. So instead of me saying, oh, x is 6, it means this would be true anytime x is smaller than 6. Okay, looking at the other example here, let's just get a marker. I can multiply this in and get 4x minus 28, but this is a 4 and that's a 16, so I'm just going to divide by 4 on both sides. So I'll be left with x minus 7 is greater or equal to 4. And then x would be greater or equal to, I'm adding a 7 on both sides. So 4 plus 7 is going to be, ooh, what is this? I am adding, right? Okay, cool, never mind. Little quick brain fog there. Sorry about that. Anyway, so now we have this equation, and well, it's not really an equation, it's an inequality, and we just know that x has to be bigger or equal to 11. So that would be true for all those cases. But now, there's a bit of a twist when we get a different example. So let me just wipe this off. And let's write something else. Oh wait, let's just do one there where there's x's on both sides. So let's do 5x minus 3 is smaller and equal to 2x plus 18. So in this case, again, I can just move all the variables to one side. So I have 5x and then minus 2x. This sign stays the same, and there's an 18 on that side, and this becomes a plus 3. So here I would have 5 minus 2x, or 5x minus 2x is 3x. And 18 plus 3 would be 21. And then just dividing by both sides, so x would be smaller or equal to 7. Okay, so till now it's very, very simple and straightforward. But there's one big, let's say, rule. So let's explain it with just if we're using numbers. So you would agree that 5 is smaller than 10. Okay, nothing weird there. Let's say I did kind of the trick that we do in normal equations, and I said, okay, let's say I divided this by -1, and I divide, or let's just say multiply. Okay, well, I already wrote the divided. So if I divide this by -1, this would be -5, right? And 10 divided by -1 would be -10. But if, just look at this, is -5 smaller than -10? No, it's not. -10 is smaller, so whenever I multiply or divide with a negative number, I have to change the sign. Now, why is that? Let's just look at 5 equals 10. Or let's look at this, 5 smaller than 10. Let's just keep with this example. If I were to half this, I just divided by 2 on both sides, both numbers would get less, no problem there. If I multiplied it by 10 on both sides, both numbers would get bigger, but this one would still be bigger than that one. If I subtracted numbers here, let's say I took a 2 off here, let's say 5 minus 2 and 10 minus 2, 3 would still be less than 8. But the problem arises whenever I change the sign, because if I'm going to multiply or divide by a negative number, then -5 is not, well, smaller than -10. So then I have to change the sign. Another way of looking at it, let's just rub this off. Let's just do the 5 and the 10 again. 5 smaller than 10. Let's say I did those kind of different rules again where I said, okay, well, I'm going to subtract a 5 on both sides and 10. So we kind of switch this around. So let's say I take the 5 there on that side. The 5 would be a negative 5 on that side, and the 10 would be a negative 10 on this side, right? So this is kind of normal. This is allowed because negative 5 is bigger than 10. But the problem again, if I were to divide by negative 1, this is very similar to the first one, but I'm just kind of showing. So here, I'm actually changing the value. This was a negative number, and suddenly it changes into a positive number. And this was a negative number, and it changes. So actually the sign changes. So because of this, I know 5 isn't bigger than 10. Because of this, the sign change that happens, I have to change the direction of the inequality sign. Okay, so let's do an example, and then we can take a look. So let's do very simple one. 4 minus 7x is smaller or equal to 53. Now, usually when you see this, I usually kind of just look at the variable and I see if there's a negative sign in front of it. If there is a negative sign in front of it, then I know eventually this will probably flip. But I'm going to do this in two ways just to kind of show or prove what's going on. So let's say this is the first way without like my rule. So what I can do without like using this special rule about flipping things or changing signs or anything. Let's say I just subtract 7x on both sides. So what I will have, I have that is over here. And then let's say I just move that over there. So negative 7x becomes a positive 7x. And then this is a 4. Just write the 4 there. And this becomes a negative 53. So in this case, I have 7x, negative 53, plus 4 would be negative 49. And then I'm going to divide by a 7 on both sides, and x would be greater than negative 7. So it's kind of switched around, but you see what happened here is I didn't really change the sign. Not really. If I wanted to rewrite this again, but I want to make x the subject in a better looking way, x would have to be here. And then you would see, okay, well, this needs to happen because x is bigger than negative 7. X has to be bigger, well, or equal to negative 7. So let's follow the rule thing that we did, or that I explained. So in this case, maybe you leave the 7x here, or now it's negative 7x. You change that sign, it's fine, or it's the same sign in 53, and we take off a 4. So I have negative 7x is smaller or equal to 49. And I'm going to divide both sides by negative 7. But because I'm dividing by a negative number, the sign has to switch around. And there you have it. You see we have the same answer. So the rule is anytime I divide or multiply with a negative number, then I have to change the direction of my inequality sign. And the reason for that is just because I'm changing the value from a positive to a negative number, which doesn't really affect an equation, but it does definitely affect inequalities.